All right, so this is lesson 5 in our trigonometry unit, and this lesson is not adding a whole lot of new to what we've been doing. It's more the same, but it is word problems. So we're giving like real life context, and how can you use trig to figure out some of the distances and things in these real life contexts. So you need to be careful when you read these. You have to read them slowly, and you probably have to read them twice. And it's a good idea to kind of like underline important information as you go, and if you get stuck on the question or something's not making sense, go back to the question, see if you might have drawn something wrong. Okay, and that's actually one of the most important parts of this lesson, is that you need to draw what it is that you're talking about. If you try to just read it and write down numbers or just put something into your calculator, you're very likely to get the question wrong. I draw these things out. If I try to do these things in my head, I often will make a mistake. It's just one too many things to try and keep in your mind, especially when you're trying to move equations around as well. So without further ado, let's start the first problem. So this first problem says a ladder is 4.5 meters long, just reaches the top of a wall. The angle between the ladder and the ground is 65 degrees. So let's draw kind of a little bit as we go. So to start off, it's saying the angle between the ladder and the ground. Okay, so the ground, we've got flat ground here, and then there's a ladder going up, and the angle that it makes with the ground, this is 65 degrees. Okay, that's 65 degrees. And it told us that a ladder is 4.5 meters long and just reaches the top of a wall. So it's going up against a wall and just reaches the top of it. And we were told that the ladder is 4.5 meters tall. Okay, so the ladder here is 4.5 meters. This is our wall. Here's the ground. There's the ladder. All right. Now it says determine, make a rough sketch and determine the distance between the bottom of the ladder and the bottom of the wall to the nearest tenth of a meter. So the bottom of the ladder is right here. Okay. I'm going to draw the ladder in blue just so it's a little bit more clear. Okay, so there's our ladder, and this is the bottom of the ladder right there. The bottom of the wall is right here. So it wants to know what's the distance between the bottom of the ladder and the bottom of the wall. So now we just use normal trig. It just took us like drawing this diagram to get to the point where we were last, like in the last lesson. So using this angle as our reference angle, this is a 90 degree here. So this is going to be the hypotenuse because it's across from the 90 degrees. And this is going to be our adjacent side. Okay, because it's right next to our angle. So then we just need to think of our SOHCAHTOA. Okay. SOHCAHTOA. And see which we need to use, sine, cos, or tangent. So we have adjacent and hypotenuse, so we are going to use cosine. Okay, so we would say cosine of our angle 65 degrees is equal to the adjacent over the hypotenuse. Okay, and our adjacent here we don't know. Okay, I'll just mark with an X. So it is the adjacent side that we are looking for that goes on top, and then the hypotenuse goes below it, which was 4.5 meters. So now we just need to solve for X to figure out what X is. So we try to get X on the top and by itself. It's already on the top, but we need to get rid of that to get it by itself. So we can move diagonal across the equal sign to bring this to the top of the other side. So that means that this will become then 4.5 times cos 65. Oops, not 6.5, 65 degrees. And that's equal to X. So in our calculator, we're just going to punch that in, and that will give us our answer. So 4.5 times cos 65 degrees equals 1.9. 1.9, and this is in meters because our other answer or other measurements in meters. So X is 1.9 meters. That means right here is 1.9 meters. That's what we just found was the distance between the ladder and the wall, 1.9 meters. And we're done. Okay, so really the only thing that was new there was just drawing the diagram and then using then we went back to normal trig. So the next question says, a tree is 5.1 meters tall and casts a shadow 7.5 meters long. Calculate the angle of elevation. Okay, so this is a new term, angle of elevation of the sun to the nearest tenth of a degree. Okay, so there's two things that we're going to talk about in this lesson, and they're very easy to get confused. The angle of elevation and the angle of depression. Okay, so both of these things are talking about an angle made with a horizontal line. Okay, so a straight across line. So let me even draw a flat line here. Okay, so there's a flat line. Angle of elevation is when we're going up from that flat line. Okay, that is an angle of elevation. An angle of depression is when we are going down from that flat line. So that would be an angle of elevation. Down here, I'll draw an angle of depression. So there's a horizontal line. An angle of depression is going down from that horizontal line. So this angle here is the angle of elevation. And this angle here would be an angle of depression. Now, I'll show you in a minute where people get confused, but the way that I like to think of this is imagining if you were looking straight out. So if you were looking straight out and you look up, that would be an angle of elevation. So starting with horizontal, looking straight, and then going up, that makes an angle of elevation, straight out towards up. Angle of depression, okay, this one's easy to remember that you're looking down. Okay, it looks much more depressed. You start looking here and you go down. So you're starting with the horizontal line straight across, and the angle that you make down from there would be your angle of depression. Keep that in mind when we do these problems and later on, because there's a very common mistake that gets made there. I'll draw my angle of elevation a little bit smaller over here as a reminder. Angle of elevation, let's do that in red. And we'll do an angle of elevation or depression in blue. Seems appropriate. Okay, so this question said we had a tree that was 5.1 meters tall. Okay, there's our tree. And it's 5.1 meters tall. And it casts a shadow that's 7.5 meters long. Okay, so the shadow is going along the ground, and that shadow is 7.5 meters long. And it wants to know the angle of elevation of the sun. So if we make a triangle here, okay, in trig spoilers, we're just always going to be drawing a triangle. And this is a right angle triangle, 90 degrees here between the tree and the ground. Angle of elevation, remember, is when we're from a straight across starting to go up. So this here is an angle of elevation from the straight across down, or straight across the ground, and then looking up from there. And where this is going towards is going towards the sun. It's pointing directly at the sun. Okay, that's what's casting the shadow down to here. So it wants to know what is this angle. So now we just use our trig. So this would be the opposite side. This is the adjacent side. And so that means we're going to use tangent, right? That's our TOA. So tan of x, that's what we're looking for, is equal to 5.1 opposite over adjacent, which is 7.5. So to get x by itself, remember from the last lesson that we need to get rid of this tan by moving it to the other side, but making it tan inverse. So x is equal to tan inverse. So that's tan with a little -1, and then everything that was on that side gets put into brackets. 5.1 divided by 7.5. And we put that into our calculator. All right, so when I put that in my calculator, I got 34.2. Okay, it says to the nearest tenth of a degree, so that's to the nearest degree, and to the nearest tenth would be the 0.2. There's the nearest tenth degrees. So that is this angle here. That's the angle of elevation. Now, I'm going to go a little bit faster here, but I'm going to set up the drawings. The most important part here is setting up the drawings. The rest is just review of other stuff we've done. So this example is a boat is 130 meters from the base of a cliff. Okay, so here's a cliff. We'll do this in blue. Here's a cliff, and here is the boat all the way out here. Okay, there's our boat. So cliff. The cliff is 80 meters high, and the boat is 130 meters from the base of the cliff. And we want to draw the diagram and mark the angle of depression of the boat from the top of the cliff. So if we draw a triangle now, here is the mistake that everyone makes. They say, what's the angle of depression? And they think it's right here. Okay, that is not the angle of depression. Okay, it is going from the top and it's going down, but this is not being made with a horizontal line. Okay, remember, you're starting by looking out and then looking down. That's the angle that gets made. So the angle of depression would be starting by looking straight out and saying this right here. This angle is the angle of depression. So it says determine to the nearest degree the angle of depression from the boat from the top of the cliff. So that is going to be the same as this angle right here, based on some of the some patterns that we learned kind of earlier on in our angles unit. But another way we could think of that is if we could figure out what this angle is right here, then we know that these two angles together are going to make 90. Okay, so if we figured out, like, let's just say, for example, that we figured out that this angle was 60 degrees using trig, then we know that this angle has to be 30 degrees because 60 and 30 add up to 90, and this together makes it a right angle there. Okay, so that's one way we could figure it out. We could also figure out that this side is 30 degrees, or that angle is 30 degrees, so this angle has to be 30 degrees. That would work too. All right, so for the sake of it, I'm just going to start this question, and then we'll skip ahead. So I'm going to figure out this angle here, and then I'll figure out what the angle of depression is after. So this angle, here's my opposite side. Okay, here's my right angle. So there's opposite, this is adjacent. So I'm going to use tangent because it uses opposite and adjacent. So I'd set up my tan ratio, and I'm going to call that angle x. Let's say my tan of angle x is opposite over adjacent, 130 over 80. I do my tan inverse to figure out the angle, and I would get this angle. All right, so I did my tan inverse of that, and I found out my angle was 58.4 degrees. Okay, so this angle here, that was the angle that was 58.4 degrees. But I want to know the angle of depression, which is this angle right here. So this angle and this angle have to add up to 90. So I need to think of like this plus what would give me 90 degrees. Or another way I could think of it is if I have 90 total and I take away this chunk, what's left? So in my calculator, I could say like 90 degrees, subtract this amount here, 58.4, the 8.4 degrees is equal to what? So it'd be 631.6 degrees. That is what this angle here be. And that's our final answer. That is our angle of depression. All right, so let's take a look at some more problems. All right, so this problem is talking about a surveyor who is using a transit to determine the height of a tree. Okay, so this is like a little machine here. It's on like a tripod, and it is determining the height of this tree. So it says it's placed 52 meters from the base of the tree. So that's the length of this side of the triangle. And the angle to the top of the tree is measured to be 12 degrees. So that's this angle. If the transit stands 1.8 meters high, okay, so that is like off the ground here, is 1.8 meters. Calculate the height of the tree to the nearest tenth of a meter. So this is just a normal tree problem to start. Okay, this side here is 52, and we want to find that. Okay, that I think you can find. That part's not hard. Then the word problem part comes in by saying, what is the height of the entire tree? Okay, remember that this was 1.8 meters off the ground. So once we find the height of this, we need to add on another 1.8 meters for this section right here. So we'll find that height and then add on 1.8 meters. Then, once we know the height of the entire tree, then it asks us to find the angle of that triangle. So we'll get there in just a second. Okay, so I'm just going to quickly skip ahead to show my work here, and then I'll show you about the last part of the problem. All right, so I use tan because we have our opposite side and our adjacent side. So I use tan of 12 degrees is equal to x, that's our opposite, over adjacent, which was 52 meters long. So then I solve for x, and found out my answer was 11.05. Okay, so this side here was 11.05 meters. Now the height of the entire tree, remember, that is only like this, the 11.5, that was only this distance here. We also need to add on that, or sorry, there. We also need to add on this distance here, that 1.8 meters for the height of the tripod. So the height of the entire tree is going to be 11.05 plus 1.8 more meters. So that is going to be 12.85 meters. Now, the final part says determine the angle the base of the transit makes with the top of the tree. Answer to the nearest degree. So now it says not the angle here from the top of the transit, but from the base, so down here. What's the angle that that makes with the top of the tree? Okay, so I'm going to draw that out a little bit more again, where we're saying here's the entire tree now. Not just the 11.5, but the 12.85. And this is still 52 meters, the distance from the bottom of the tree to the here. But now instead of measuring from here, okay, we're going to measure from here, the base of the transit. Here's the top of the transit, here's the base. Now we want to know what's that angle. Okay, again, it's just like our tan, because we have opposite and adjacent. But now we need to find the angle instead of the side. Okay, so it's like tan x is equal to opposite over adjacent, 12.85 over 52. Solve for x by getting rid of our tan. So we flip it to the other side to get tan inverse is 12.85 divided by 52. Put that all into our calculator to get our final answer. All right, so when I put tan inverse 12.85 divided by 52, I got 13.9 degrees. So the angle from the base to the top of the tree would be 13.9 degrees. All right, we've got one last example here. So this one says, in the diagram, the man on the ground is standing 12 feet from the wall. Okay, so this distance here is 12 feet. The angle of elevation, okay, remember that that's starting with a straight line, and elevation is then looking up from that straight line. So this is an angle of elevation. So the angle of elevation from his eye level to the eye level of his wife in the building is 62 degrees. So from here to there, this is 62 degrees, there to there. If the man's eye level is 6 feet above the ground, okay, this is why I'm writing things down as I go. Okay, his eye level is 6 feet above the ground. So this distance from his eyes to here is 6 feet. And his wife's eye level is 5.2 feet from the top of the building. Okay, so from the top of the building to here is 5.2 feet. Determine the height of the building to the nearest tenth of a foot. Okay. So we want to know the height of the entire building. So it's already told us this chunk here. Okay, that's 6 feet. And we know from the top of our triangle here to the top of the building is 5.2 feet. We just need to know this bit in the middle, and that is just this length of this triangle here. Okay, so this actually is not quite as hard as the last problem. It's just we need to solve what's this side. So we'll call that one like our x using our normal trig, and then we just need to add 5.2 feet for this part and add 6 feet for the last or for the bottom part, and that will give us the height of the building. So we have our opposite and adjacent side here. So we're going to use tangent because that's our TOA. Okay, so we'll say tan of 62 degrees is equal to opposite over adjacent. Our opposite side was x. Our adjacent side is 12. And to solve for x, I'm going to move the 12 up here to get 12 tan 62 degrees is equal to x. And put that into my calculator. 12 tan 62 degrees is equal to 22.5. Okay, so 22.5 meters. So that is this distance here. The distance of the entire building, though, the height of the entire building, is that plus this 5.2 meters plus 6. So 22.5 plus 5.2 plus 6. So that will be 27.6 7 plus 6 more, 33.7. 33.7 meters will be the height of the entire building. Okay, so thanks for sticking with that video. I know it's a bit of these can kind of be a bit brain bending, but read the question more than once, draw a picture, do things as you go, check your work, or check back to the question if you're making mistakes or you feel like you're not sure what's going on, and make sure that your angle of depression and angle of elevation are not getting confused by writing them in the wrong spot. So good luck with the assignment, and I'll see you in the next one.